Hello. This is maybe the toughest tough video I've ever done, and what it is I try to sum up all notes that I have taken within the last month. Some of which I have actually put into a video. Some of these videos I've even published on a YouTube channel. It's kind of like a big book review I did, I think something like 6 months ago, where I reviewed all the books I have read, which were about 70 to 80 books, and I ordered them, which were the most important ones, and why did I read them, and so on. And now with this here, I want to do two things. First, document what I know at the moment. And it is the other thing, which is even more important for me, is that I want to have the whole picture in my head. Because what happens is that I usually work on, let's say, 1 to 4, 5 of these sheets per day. Each of these sheets is kind of a candidate for a meta principle, a meta paradigm, a principle. And so this one, for example, is fractal modeling of the quantum field of the universe, you know. And so the trigger for that was a general definition of complexity. I think it was triggered by a video from Jean Carroll. And I wasn't happy with the mathematical definition which was given there. So I thought about what is kind of a definition that to me makes sense for modeling the kind of the theory of everything, you know. So I came up with that the number of subsystems you have in your simulation, in your model, you know, that are required for your model. So for quantum, you need then the electrons, you need waves, and so on, and you define those, and so you have 3, 4, 5 components, sometimes even less, and then you try to figure out what it is. And now, what are subsystems? And usual, you know, things that make sense are subsystems that are loose, entangled, because the quantum field means everything is a wave and everything is connected to everything. And that is actually the definition of the system. What belongs to the system is that has influence on the system. So otherwise it's not part of the system. Now we could, I've done some research on that, whether it, you know, it could be that it did not, it wasn't part of the system yesterday, but today it's part of the system. I believe it's not like that, but then it depends a little bit what you defined it, you know. So it often boils down to what do we talk about? What is matter? You know, a wave or whatever you want to. But what is what is the wave, and so on. And I have an idea already of what that is. That is this fractal approach that actually then defines itself. And I think there are some theories on that it kind of is an initial, you know, disturbance of a quantum field, which is in vacuum state, and then it kind of evolves into, you know, this what we have now. But anyway, so it's about complexity of of a system. So so you have components, like when you model something. Let's say you model, you know, the street traffic. You have a car, you have a pedestrian, and they are, you know, they have a division line. So you can say here ends the pedestrian and here ends the car. After a crash, you might not be able to make that distinction so well, because, you know, maybe one of the two opponents in the crash actually disintegrated, but which is one of the things here. A spin-off of new instances now, that would be like a childbirth or something like when you collide two particles, then they spin off and create a second one, and that makes the system very complex. If you only work with, you know, 3 things and then they never change, then okay, then you add dynamics to it, which is this, you know, so the time, you know, so you can statically look at something, but then you could also wait for 1 billion years and then see what happened, you know. And and then here, so a number of subsystems, it's the number of fractally composed clusters of different levels. So that means you have subsystems and they are divided, like, for example, a thought we have, which is also a quantum field, represented in a quantum field. Your thoughts that you have, your thought, a meme I call that traverses your brain, is kind of a quantum field, but it traverses real matter, like atoms of your brain, your gray cell. I use it, your grayware. I use the term plastware because the plasticity of the brain. And so it traverses, the meme traverses your brain, and then you lift your arm, or you drive a car down the cliff. So that means that is this, what I call the intelligent transistor, because your thought, which is a quantum field, can actually trigger something that is like orders of magnitude like 20 higher than your thought. Your thought was just, very, very tiny waves, and then the car crashing, or you press a button and then atomic explosion happens on the Earth, and you destroy the Earth. So that is a huge transistor and would have, a huge it has a huge impact, which is exactly that, how likely it is that an event can leave a subsystem. So that means the thinking subsystem raises your finger and you press the button to press to the atomic bomb. And then that would be kind of a huge like orders of magnitude change. So maybe that is like 50, 10 to the power of 50. And then if you want to kind of simulate or predict something like that, that completely blows the system understanding, because the result of the model-based simulation it would then be completely useless. How could you kind of predict from a thought going through your brain, traversing your brain, pressing a button which then makes the Earth explode? That is a complexity, that is very, very crazy. That's one of the, that's a huge, but not the biggest complexity. I think I have some more on complexity. But this is just to understand what I'm thinking about at the moment. And so this is already 7 minutes, so this will blow my mind, and also I think nobody will be able to follow that. And then the required precision, and that is actually plays into here. The precision. You have to watch it. So then, in the explosion of the world, do you have to look at quantums inside something? No. And so that, and the result of actually this, the modeling of the quantum field of our, the universe composed of quantums, quantum fields, that is something where you could immediately say, forget simulation, forget prediction. You can predict at a human level, like Newton did with the apple that falls onto with the gravitation on the Earth. And then Einstein came with his relativity theory, and that is fine. If you then on the edge, you go nearer to the speed of light, and then you go into the Planck quantum, you're quantizing and look at how big the smallest part is, and so on. So you go all the way out of human scope, natural human scope, and then it becomes really, really complex. And here, that complexity blows everything, and so that means we don't even have to consider this. This doesn't make sense. So the what I take from this 10 minutes is it doesn't make sense to model everything. We have to grasp some parts, and what, for example, in CERN they do is they grab some very, very, very tiny parts. The parts are tiny, but they grab just a few of them, and they are very similar, and they look into what they disintegrate. That was a level of complexity, and I was not happy with the definition, mathematical definition of complexity, because what is it worth to kind of have a formula if it doesn't serve you. It just makes, okay, it's so complex you cannot describe it. You have to go to some form of abstraction. Okay. Then before that, I did, exactly. What I did is I compared what this simulation I was just talking about to kind of simulate the Einstein unified field theory, what he was working for 25 years on, the last 25 years of his life, which was kind of, which I see always as this idea to have the quantum field of universe simulated, emulated in my brain. So how good, and I come to that, how powerful our brain is, and how it should kind of structure the universe to be able to grasp it. But that is my first system. That's terribly complex. But now if I look at a very, very less difficult thing, would be how to build an autonomous driving car, and how to give this autonomous driving car, which is this highly automated driving function here, that actually has to drive on the earth with its streets. And then we let it drive in a model. So we have objects, and then we generate from the objects, we generate a video image, and then we put a model of a video and have it filmed, that object which we created, that the film we created from fake objects like a video game, and then we give that into the camera, and the camera then generates objects, so sensor data fusion, so objects, and maybe there's radar and other sensors that go into here, and so we have then our data, and then the car says, I'm here, I'm there, I'm whatever, I have to brake, I have to accelerate, I have to turn left or right, and so on. And that is a relatively complex thing. And here on these things, I think worldwide there are maybe 100,000 people working on this. So this seems to be very, very complex, but it is, as I wrote here, if I compare the two, so we work on this with 100,000 people, and it's very tough to get this highly automated driving car on the road. I will succeed in maybe 5 to 10 years, but we will. We already have succeeded, because you just let the car drive by, I don't know, the speed of a pedestrian, stick a 6 kilometers per hour sticker on the back of the car, and it just drives everywhere, and in case it does a deadlock or something, like sits against I don't know, a wall or so, you have an operator that then unlocks it or whatever. So if you compare the two, then I would say Einstein's unified field theory is much bigger, at least 1,000 times bigger as this, and not the thing is, what Einstein kind of wants is, he wants to look at one single quant and then maybe understand of what this quant is composed and what it is, what holds the world together in his innerst. But what I would look at is the simulation of the structure of the universe. I have another thing. So that is, and here I say it's at least 1,000 times more complex, because I might have to, maybe it's only 100 times. You might have 50 components that have to interwork, dynamically interwork. That's already, or just adding dynamics to it is always terrible in terms of complexity. And here you would have maybe 1,000 objects. So in order of magnitude, maybe 2 to 3 higher, this system. But now the question, what is here? Quality score, which is all, this is the reality, and then this is fake, and then we have to define how good our fake maps the reality, but that's a side note. Now the complexity, so this one 1,000 times more complex than this one. However, the real question is, what do I want to achieve with simulation? So what do I want? What is my question? So I cannot say, let's understand the universe as a whole in terms of quantum field. No, that doesn't make sense. It makes sense a specific question to this. So that's the very important thing to note. Please, we ask a question predict this or predict that, or how likely is that this happens, or how likely is that this happens, and then we model it, and then we think that model through, we calculate it through, and then we have an answer. But this quantum field approach, that is, forget it. It's the same here. Forget it if you do that. If you use real video data, real radar data, laser data, and so on, and you try to simulate or emulate everything, forget it. So the general answer is, it depends on what your objective is of your simulation. So what is your question? Now, what I found out, and I've been researching for all my life, so more than 40 years, as a kind of somebody that understood physics and whatever, philosophy and human behavior and all that, and how the brain works and so on. So the trigger for this was, I was preparing an espresso, and I thought about that most scientists are, in German, that's nice, Wissenschaftler, so creator of wisdom, but they are actually, that is a bad person, Wissensschufter. So that means they are Schufter, they are criminals. So they are criminals of truth, of knowledge. And now the reason is for that, so they are not humans that create wisdom. So most of the people are not that. And now why is that? And the reason for that is because there's a difference, a discrepancy between, a chasm, between the knowledge they have, how good they are, they compare themselves with a Nobel Prize laureate and then with another colleague, and they read a book and they thought, oh fuck, I don't understand this, and all this, and there's a colleague, and at this universe, oh, they are further. But on the other hand, he's maybe a little bit tired, or he doesn't, it's not his vision of life. I come to that. So it's not what he wants to achieve, because maybe he wants just power and status. And so I define these people as weak people. Weak is often associated to female. And why female? Because in nature, like if you go 10,000 years, sometimes even like only 100 years or 100 days back, or 100 minutes back, the women are usually physically weaker, and for that reason they can be oppressed by men, and that has happened definitely 10,000 years ago, because men were strong and women were not strong, not as strong. So the women are usually attached to weak and the men to strong, but that is not a one-to-one relationship. I would rather say it is a lot of men are very, very weak people. And that is why they turn into evil, into lies. That is what they do. And because only a person that is strong, independent, like, for example, all the philosophers or Diogenes, they are independent. They say Diogenes, when asked by, I think, Alexander the Great, what can I do for you? You helped me so much. You increased my wisdom by so much. You can have anything. He could have had a palace and slaves and whatever. And he said, oh, could you please move out of the sun? Because he didn't want to have a house. He just lived in his, wooden barrel. So that is independence. And so he was Diogenes. Although he had nothing, he was strong. He had nothing, but he was strong. And maybe a lot of very powerful people, they are weak. So it's just a discrepancy between what they know and what power they have. And if you have a lot of power, then you will use that power to kind of maintain your position. So like a professor, for example, he achieved his role, maybe because he was good, but then his wisdom actually was weakened, and others were more knowledgeable, but he still has the power. So he will not allow that this other person that knows more kind of moves up moves ahead of him, and so that is that creates actually this huge problem. And now the reason, how can you solve this? And you can solve it actually with a vision. With a vision that says, I want to increase wisdom and truth and know-how in the world and distribute that, if you have that vision. But most people don't have that vision. And so that means most people have the vision, I want to survive, I want to have a nice partner, I want to have a good house, and I want a car and holidays, and I want this and that and this and that. And I would want to be seen as high status and powerful and whatever. And they see, with pure wisdom, that doesn't work. So with power and, that doesn't work. And so they use the lie. They use lie and to actually move or keep themselves in the position and maybe even move up in their powerful position. And that is why I say that is true for almost everybody with power. But in any power knowledge system, that usually happens, that you have this chasm between knowledge and power. And it also applies to scientists, because scientists are often seen as, they are scientists, they must know everything, and they are so independent. And that was maybe in the good old days where people were honest, if such times have ever been there. So there is, the trigger was a virtual discussion, which I have actually a lot. I actually do have a lot of virtual discussions with whoever. I think about a person, and then I know how he thinks, or I simulate him in my brain. I have a little avatar of this person, and I know kind of from the interactions I had with this person, kind of I rebuild what he thinks, how he thinks, his meta thinking patterns and so on, and his arguments. And so I can discuss something with him with a person 10 minutes or so, and I discuss things with him. He answers, I answer, and so on. Now, my claim is, that's, I think, a nice thing for my vision. That is, my claim is, it is possible to understand and to explain how the universe works. That is the kind of this quantum field theory, unified quantum field theory from Einstein. I believe that this can be found, and it is possible to explain it to somebody. There is different research I did on this topic. It could be that it is so complicated. I have another thing on that, complexity the brain can grasp. And it could be that we need artificial intelligence to explain to us how it works. And it could be that we are too dumb. So that means our brain is too limited, our fast-thinking brain, and maybe we can build some crutches with slow thinking and so on. But it will be hard to grasp, like Einstein grasped. Einstein was able to think in his curved space-time continuum. Some people are able to think in a quantum field. I sometimes have the imagination that I can do that also, but then I come to some question and I think, wait. Now, now it's a circle. On what do I base myself? Is the matter? What is the matter? And then I lose it. But that is one of the things. But I believe that it's possible to explain what the base mechanism of the universe. But it is impossible to simulate it. That's what we learned from this other example I showed. And that means we cannot give exact statements on what will happen. We can't predict the future. That we can't. So we can understand how it all works, but it's too complex to say, because it's a dynamic system composed. So this is exactly why I then did, I think on the same day, exactly. So why I did then 10 hours later this fractal modeling of the quantum field universe, and where I explained that this is not possible. So here at the thought, I had a discussion. That is my normal thinking pattern. I had a discussion with a virtual person of usually opposing ideas, and then I explained it. I have a feeling that this possible, not possible, and then my brain works on it. Because then I did something completely different, and then my brain, after some hours, comes up and says, "Look, that is the system. I solved it for you." And this is one of the strategies I've been using for maybe 3-4 years, very, very carefully, and I use it every day, every minute I use it. When do I need my fast brain? When do I need my slow brain? When do I feed my fast brain with information, which is a serial thing, so serialization, so I read something and so on, and then I feed my brain, and then I give it a task, a task I really want to achieve. And then the brain does that automatically, the fast thinking brain. It comes back and says, this is the answer. And then I serialize it, I write it down. And by writing it out, writing crystallized thoughts, or like this video, if you do a graphics, that is even better. And then you actually, because you're fast thinking, associative thinking is not logical, so it cannot find design flaws. It cannot find, it says there's a relationship between here and here, and I conclude this, and then you do an analysis, a slow analysis, and say, oh, wait, here is a little design flaw in your associations. Maybe the subsystem is a little bit different. There's an order of magnitude, 2 orders of magnitude in between. So the relationship you have here is not right. And then I maybe research, and then I feed my brain, fast thinking brain, again with my slow feeding, because serial, it's, reading and listening and, seeing a video and a graphics is very slow compared to like orders of magnitude 2 or 3 slower. No, my serial logic brain is maybe 100 or 1,000 times slower than my associative thinking brain. I come to that later. Okay, and even the interpretation, of the past is because of the high complexity of the universe. Also in this very, very small, also in the tiny things, is not possible. Is not exactly possible. Obviously, like the dinosaurs died. They died. Yeah, maybe. How did they die? Was that within a day or a year or 2 years or? Well, we have found this and blah blah blah, and we think, but we cannot. It's just too complex. And what time of day did the meteorite hit the Earth? How big was it? Blah blah blah. Yep, we don't know. Oh, and if somebody says, I know, it was at 3:30, and I say, was it 3:30 and 4 seconds? Oh, and so how exact? Now the question is obviously, do we need to know that? And this is one of the things that saves us, saves us, because we don't know, we don't have to answer it. So, or even question it. So what is this graph? So, okay, what I think is, because we can understand, but we cannot predict anything, So, but what I say here is the human knowledge and wisdom. That's the human bag of human knowledge and wisdom, and there is a constant growth. And I might say there is an asymptotic, towards a reality. I make a question mark here whether that's true, but I think, and maybe we go infinitely to find out what keeps what holds the universe together. But I think it's a growth that might never reach the highest level. Okay, so there's a growth in knowledge and wisdom. So at a certain point, we know how the universe works. Quantum field theory, that was Einstein wanted to learn. So we found it, happy. But what is the benefit out of it? And the benefit is red or green, is good or bad. And so what benefits does the mankind has from understanding the world? And so there is kind of two things with it. The neocortex, I think, is very happy and can produce eternal life, and all is possible attitude. That's in the neocortex. And maybe we can, eternal life could kind of move into artificial intelligence. That could happen, but on the reptile brain actually is unemployed. So it's not that people are unemployed. No, the reptile brain. So something that the nature has given to us. The reptile brain is very, very important for us, for our happiness, for well-being. But the reptile brain is unhappy and it has nothing to do. So maybe we need to use the neocortex to create, like in Second Life, create a task for the reptile brain, so that reptile brain is also happy, no? And that, we could think of a world like that. I don't know how, I sometimes am scared when I look at that, but yeah, this could happen. Fine. Then if that happens, then it happens. That's anyway one of my favorite laws. What happens, happens. And not to say that I don't try to kind of make the bad stuff go down and the good stuff go up, but what happens, was out of my control. Now, my motivational journey towards my vision, as a human made of flesh and blood, So yes, so that means because my vision is that I'm only interested in the increase of wisdom and truth and knowledge, but as a man, as a human made of flesh and blood, what can I do essentially? Oh, yeah. So I now understand I should have written trigger here. Now, what was my trigger for this email? Because I created 18 months ago, I created a YouTube channel, and it was all around eating. And that was essential. Because everybody can do that. I don't think that a lot of people would be happy to do what I'm doing. That's my vision. To become, not, I don't want to, it's not, I want to become the best thinking person. And I'm very humble when I look at, people that present on the internet and on YouTube videos, whether that is Peterson, Jordan Peterson, or whether there's Jean Carroll, Sean Carroll, and so on. So, I'm delighted to hear of them. However, that my vision is this, and I want to achieve it. However, I think most people won't be happy with that. So there's maybe 1/10 of a promille or something like every, one in a city has this vision. So, but what everybody can reach is eat healthy and become healthy. So I've created this channel, Happy, Active, Healthy 100+. So live as long and happy and active as possible. And what I do is very, very simple. So I drink a lot of water, and I eat about 50 different types of food, all of them with this thumbs up, and during only 2 hours per day. So I kind of from 12 to 14, it's my feeding period, and after that only 0-calorie stuff, so water, tea, and coffee, black coffee. That is what I do, and obviously kind of on the side. Often it sounds through, aren't you so such a perfectionist? That's what I'm exactly not. So 90% of the time I do that. And so it's kind of what is written in the Bible. So 6 days you work like hell, but then on the 7th day you can relax. So, and I see that exactly in that way. So on 90% of the occasions, I kind of do that. And then the others, I do whatever I feel to do. If my body tells me hang around or eat chips or have a nice sweet cake or a cappuccino, fine, go for it. And a French croissant with a cafe latte, and you dip that is fantastic. You have the croissant, you put butter on top, you put strawberry marmalade, strawberry jam on top, and then you dip it into your cafe latte or your cappuccino. Oh, fantastic. Cafe latte is better than cappuccino in that when you dip it in. And obviously I do sports, but sports I do in a way which is extreme sports. So for example, I sometimes decide, okay, now I do 100 kilometers bike trip, out of the blue. I drive normally 10 kilometers, 20 kilometers, and then I say, oh, it's a nice day, 100 kilometers. Or I say, I go 30 kilometers of hiking. And then, interesting, I then just leave the house. I drink 2 liters, and then I just leave the house. No phone, nothing with me. I just good shoes and, a jacket that I don't, against the weather. But then I just walk. That's it. And I don't take the car and drive, I just walk. And then I walk in nice places, look at nice places. Usually I'm upset that I don't carry a camera, but then I go back and 30 kilometers, that's it. And the other thing is 1 minute extreme training. That's another thing I do. So that means I stand in front of the mirror in the bathroom and I do exercises that are so extreme. You take your muscles and you stretch them. If you do it more, you get a cramp. And I do that with every muscle I have. You can, after a while, you are able to contract 10 muscles at a time. All the muscles from the leg are pulling up, and then all going down, and then the shoulders, the neck, whatever. And you do that. And usually I do that with music, and then put a kind of a table music dance within that. So that's 1-2 minutes, and that's it, and that's enough. Every once in a while, an extreme walk or extreme swim or extreme. So swim, you go on the sea. You get up at 6 o'clock. The sun comes up. You jump into the sea and you swim 2 kilometers. That's it. You swim. Like we come from water, then just swim. And obviously, you should train, and it's a growth and so on. Don't do it right away, but you get into it, and then that's it. So that's one of the things. So eating, and then the sports, and then like on 10% of the occasions, this 1 day in a week, follow your instinct. Just do whatever you want. Be an animal. Reptile brain, do whatever you want. If you're a man, go to a woman and say, oh, wow, you're great. Well, if you're in a partnership, maybe not, but go and ask her. She will say no, but it doesn't matter. Just use your reptile brain and say, wow, I'd like this woman, really. Or I'd like to, you go through the forest, for example, at night, and then you hear, and you think, oh, there's an animal. And you get really into your reptile brain, what is going on? And all your senses are completely alert. That's your reptile brain. Use your reptile brain. And then also be an empath, so use your limbic system. So be cozy, say, I cuddle, and so on. So try to also satisfy your limbic system. I'm part of the community, of my family, and so on. So follow your instinct, And I think following your instinct usually do not work in your neocortex. I think the instinct is usually not logically using your neocortex. Your instinct is your empath, your limbic system, which does not have to be an empath, your limbic system kind of uses the slave neocortex to get you there. So like your limbic system, like you see, oh, I would like to meet that girl or so, then your limbic system will, if it's clever, it will ask the neocortex, how can I get that girl? And the neocortex will find a lot of lies and things and whatever tricks tricks and so on to get there, to get what the limbic system wants. So that is what the neocortex has been designed for. Yeah, and so I'm a little bit lazy on that, but in a kind of a 10% follow your instinct, and then a lot of people then say, it's not possible for me to do that, and the job and what you have to do and family, it is completely independent from this. It's completely independent, or not completely, but it's not that much entangled. This extreme sports, you can do that. Get up at 4:00, come home at 9 on a Saturday, on a Sunday. At 9, your family gets up, you have done 5 hours of walking. Then, yes, a lot of people say, no, I can't do that. Okay, then fine, don't do that. But that is my journey. That is my journey. And my journey is always this, my 24 hours of 24. I'm in full control. And if I want to stay up 24 hours, I can do that. And if you look at kids and, when you do crazy things, you don't sleep. On New Year's Eve or something like that, you don't sleep. You can do it. You can do it. But it depends. You have 24 hours. You can decide when you sleep. And normal, I would say, here in the 90%, it's better you go to bed at, 10:30, 11 o'clock or midnight, and then you wake up after 6 hours. It depends a little bit. You wake up and that's it. Yeah, but at the rest of the day, it's okay. Then there's a job. Maybe you have 10 hours of job. Okay. You sleep 8 hours. Then you have 6 hours. Then 6 hours. And the eating here, you save a lot of time. But let's say you eat. Then people say, I can't do that. Yeah, why not? You come home at what time? At 6 o'clock? Okay, then eat from 6, or which is in Germany, it was 18 o'clock, to 20 o'clock. Yeah, to 8 p.m. So eat 2 hours, you can do it. And then people say, yes, but my family has breakfast. Yes, have breakfast with them. Tea, green tea, no milk, nothing, 0 calories. Anyway, you should drink a liter or 2 of water. You sit with them. You have tea. That's it. And the first week you might suffer. The first week you might even eat one of these Nutella breads that the family eats. But, after a week or so, you kind of are immune to it. And every once in a while, here, go for it. Follow your instinct. But not more than 10%. Okay, that was it. That was kind of the my journey. And it didn't take a long time. It took maybe 18 months or so. Maybe with preparation, 2 years to reach that level. Okay, that is, I think I'm now at 42 minutes. That is a lovely thing I had. I was with a friend, and he actually said that people that say that they know that are arrogant. And so because we had a kind of a dispute, and as always, I thought I was right, and he said I'm arrogant. And then I thought about what is arrogant? What means to be arrogant? And I think it's a clash between, if you have two people, person B thinks that person A is arrogant. Now, the reason is when this person B's view of that person is different than the person is presenting himself. If there is this mismatch, and obviously in this direction that he thinks not as good from him as he says he is, and then he says he's arrogant. But only if that this is this here, but only if he's interested in that topic. If this guy says he's a very good plumber, and he says, I don't care about plumbers because I'm a scientist or a doctor, and he can be a great plumber because he's crap anyway, because he's only a plumber and I'm a doctor, then, this person A couldn't even be arrogant, But if they, for example, are both doctors, and he says, look, colleague, this and that is wrong. And he says, no, it's not wrong. He says, oh, look, I studied this. Oh, and then he comes over as arrogant, something like that. And so, belief. Oh, yes, and the worst thing is obviously when it goes against the belief system. So when we hit the really belief system is the vision. So the word everybody's equal. Men and women are equal. All people are equal from birth and have to be equal. Outcome equal. They have to be. And the thing is, they should have the same rights. But if they are not equal, one wants to sleep long, other wants to get up early, and one wants to sit on the sofa, the other wants to go hiking. So they're different. One becomes a doctor, one a plumber, and so we're different. That's it. And so, but if it goes against the belief system, then then this can actually lead to murder. This is from the Bible, the Cain and Abel, the murdering the brother. Because this behavior here, so arrogance is kind of the starting point. This is, I think nobody murdered anybody because he thought this guy's arrogant, but that then builds up and builds up and builds up, and then that could lead into something like that. If the world here, there are lots of people telling him that this is an asshole and he's dangerous and he is not right, and the group and the dynamics of the group, and then you could have things like that. Okay, now. Here, another, I think it was the same day, it was in the morning, 8:05. That was great. I had an internal discussion corresponding to the neocortex, the intellect, the limbic system, and the reptile brain. And I was thinking, oh yeah, that was a good example about mega paradigms, a lot of people say that, look, the thing is, when you see, put it that way, okay, a normal day of a human consists of orders of magnitude 50,000 big things. I call them memes, so impressions he has, which means, for example, the alarm clock rings or something falls down and so on. And then the selection is a vision-relevant selection of the brain. So the brain says, if this event is relevant to reach my vision, then I use it. And usually you come out with like 100 to 1, so 500 memes, maybe 100, I don't know, orders of magnitude, 500 memes a day, which are relevant to get your vision through, yeah? And now the example here is, let's say this man here, this lovely man, is driving with his car to his date, and here's his date, yeah? And here's his date. And so he stands, and his precondition is, I'm late. Oh, I'm late. My vision to have an encounter, my date, is in danger. So he comes up at a traffic light, and he says, fucking traffic light. I hate this traffic light. It takes ages. And then he turns green and he comes to her and he will say, oh, the traffic light. So he starts like that. He saw this meme. The traffic light was his meme, one of his 500. But if the same man would have a lot of time, he's on time, he's ahead of time, and he sits at a traffic light and he enjoys the music. In his radio, the music is playing, and he sits in the same car. Also this person, I'm too late person, was sitting on the red traffic light with the music, and he selects, I have time, I relaxed, because it has no negative impact on reaching the vision with this girl here. And that means he arrives here and he hums I don't know, a song and says, wow, I heard, I have to show you, I have this really great song from, I don't know, Queen or whatever, I want to break free. And come on, we listen to that together. Yeah, so the selection here is vision relevant. So if you have a vision, your life vision, and it's endangered, or there's something that is in favor of it, you select those. And you don't know even that you select those, because that is your subconscious doing that in general. So I thought that is a nice example. So either you have a traffic light, which you remember, or which you select, or you have a song that you remember in the same situation. Okay, we are at almost 15 minutes. Now, what is that? General trigger. Oh, that is fantastic. I'll do the. Oh no, this is great. This is one of my favorite here. It is how many serially and parallel active associations, and I come to that on the backside, associations, does your simulation of the reality have in your brain? Watch out, we simulate the reality. It's not, in 99% of the cases, we live in our own simulation. There's a video on that. And not in reality. Reality is when we hit a wall, but simulation is that we know that we will hit the wall because we experienced it, and our reality, our simulation in our brain tells us there's a wall and don't run into it. So we live in a simulation in most of the time. And so how many active associations do you need to predict or to predict reality, or to move in this virtual real, in your simulation, in your virtual reality, to at the right level, like the brain of a snail with 14 cells will not be enough. So I then thought about, okay, this is the quantum field of universe. Okay, that's the thing. But obviously we do not, I had that earlier, we do not try to model the quantum field in our simulation, but thank God, the quantum field has a structure. So there is a structure, and there are objects, and there's a car, and there's a street, and it's moving, and gas and air and heat and all that. So, and now the thing is, in order to understand, and this is the great unified theory of everything. This is my goal, to model that with the right exactness or precision. How good must my simulation be here? And now I thought about, usually if you look at a neuron, we have 10 to the power of 9 neurons in here. So, and then each neuron, they are structured in a specific way and so on. Not all of them are used for the neocortex. They are used in all the different systems, the hippocampus, whatever we have in there, the limbic system, the reptile brain, and so on. And but most of them are obviously in the neocortex. At least I think. Yeah, I think so. Now, but I don't know the exact numbers. Now, in general, when you build a neural network, let's say, each nerve cell has one axon and then several synapses, which are a few hundreds. Now, why do I put 7 here? Because one synapse alone does not transfer information. So it has to be kind of a cluster of, synapses that meet a cluster of neurons. So you can say it's not 100 million neurons and each one carries intelligence. It's already, that's a fractal principle again, for associative thinking. So I would think that 7 is a good number, because it's like from experience, we know that we can remember kind of 7 things and kick them around in our brain at the same time. 7 plus minus 2 is this rule. And I take 7. But now, and we come to that on the backside, and it's really, really interesting. And the 7 can connect to others, and they can carry also 7 small memes. A meme is kind of a contained information. You can, it's easier to remember a meme, which is a thought, which is a logical thought. And take a joke, for example. A joke is a meme because you cannot tell the joke differently. You can change a little bit of it. You can, somebody says, begins a joke with a man is driving in a car, but maybe he could also say a man is driving in a small lorry. Maybe that joke works as well. So but the joke, the point of from when you laugh, it builds up, and then tension, and then what I thought is different, and so that is a meme because you cannot tell it differently. It stays together. It's like a gene. So and that is the meme. So the meme hits an area. This area has 7 associations to others because it's clustered. 7, and then that hits again 7, and now so that means that you have 7 directly, 49 indirectly, and as 2 levels you have 343 associations or memes that you kind of grasp, and come to that later. So I think that in order to understand reality relatively well, like these quantum fields, we have that. That's kind of, we need at least around 1,000 models that have connections to each other. And we need to grasp them like Einstein was thinking in his quantum field theory, in his relative bent space time continuum. He could think in that, but thinking in that, he had to have several, maybe that was just 49, but I assume more. He need to grasp that at the same time, and I come to that on the next page, what that means. So that means, in order to understand that, you need orders of magnitude 100 to 1,000, well limited or well confined, by quantum, by orders of magnitude models. So structural models, these ones, and so that means so each model is one of these quadrants, which is then has to be thought of in the brain, and you have to have it in the brain. This is the kind of the modeling. And I think it's kind of 3 what we could do. And now that's the explanation now. Oh, one side note, because we come to the next slide. But one side note, if you are afraid, if you have the reptile brains actually, and I think I come to another one. Yeah, the next one is, you have the sigmoid function. And the sigmoid function then would give you, would say the sigmoid function, if you are afraid, would kind of alter. That is what I think. I need to research that a little bit. It would alter, and it would then make every cell in that area of the brain that is attached to fear, that it switches, kind of, that it isn't able to do these associations. So it can only think of one thing. For example, there is the leader, he tells me what to do. Oh, there is somebody told me to do that, I'll do that. Or I just don't do anything, I just sit there. No, I don't think. So fear triggers our brain, so the reptile brain triggers, so it emits something that we cannot think in this depth. And I think if the reptile brain, let's take that out. And so a good, like a bad, like a a very simple person, simple-minded person, he has maybe 7 associations that he can have. A very well-educated person and very intelligent. It can also be partially intelligent, so some areas more, some areas less. But that is plasticity of the brain. You can train that. You can grow that. So it's not that you are stuck with something. If you try for 10 years, you'll reach any level you want. You're 10, 15, 20 years. You reach any level. So I would say we can have about 300 associations at the same time. And now I come to the same time. Why is that the same time? And therefore, we have to look at this is a brain, a part. This is a part of a brain. There, a problem, a challenge meme, a question comes in. That's the challenge meme, comes in. And now the challenge meme is a combination of, it comes from your ear and then is a sequence, a dynamic sequence, and so on, and the memory effect of the brain, of the cells, it swings, and it travels to that part of the brain where it should go to. It comes from the ear or from the nose or from everywhere where it comes from, reading and from your eyes, and it goes into the brain. And then this meme looks, and the brain is made like that, but this pattern, that's actually the pattern which I refer to very often with, if in the Waldorf school from Steiner, when they say dance your name, and that's a fingerprint. So let the person dance, and you can see whether it's a harmonic person, what his name. It could be like just today he's kind of aggressive or he's soft or whatever. But dance your name is actually a good thing. It's a good thing. You can see, if you're experienced, you can see whether he's harmonic. Maybe if you ask him what kind of music do you want and then dance, then that's even better. Okay. Well, maybe not. Maybe that's then misleading, and everybody is kind of taken by the music, and so it's overlaid his character. I don't know. So, but that is the principle. You have a meme coming in, and this meme hits your brain, and in this brain, the synapses have been within the years of your education, of your life, has formed in a specific way. And now the thing is, this traverses it. And in the end, there's a respond meme. And now the thing is that it puts itself here and then triggers other areas of the brain. And it then, you think about it, maybe you need 20 steps, 1 second. I think they go like 50 milliseconds or something like that is the trigger, but I would have to look it up, maybe 40, 50, 60 milliseconds a brain, like when a clock is. So, and then when you have an association of this, it triggers something, then it triggers that and that. But now to reach this level here, only those were counted that, because there's a clock that then say these ones move in and these ones move in. And so you will have some that don't make it, into your response. And that is exactly because you can only, the window is 2 to 3 clocks. And if we now look here, if it's 2 clocks, you're at 50. If it's 3 clocks, you're at 340. So it's maybe in between for a normal person. And if you're good, then actually your brain is able to wait a little longer, and you're at 4. And then you're at 2,500 things you can actually keep. And that is a big question I have. Maybe that's possible to train that, so that you slow down this clock and you allow more memes to still make it to your next hop. And then you consider them. If let's say you have a clock of 1, then all these are not considered. All these, and I think that is kind of an explanation how complex a brain has to be in order to grasp at the same time, it's very, very important. A lot of people say, no, we can think serially. Yes, that's true. But serially, you are 100 to 1,000 times slower. I would say in occasions you are even, you are orders of 1,000,000 or infinite away. The infinite example that I have here is this. There are lots of people, or many geniuses, but take, for example, this mathematician from India who lived about 100 years ago, Ramanunyan, I think is his name, and he taught himself math, and he looked at the most complex formulas. And within seconds he knew the solution. And that is a highly parallel brain. That is not a serial brain. And that's exactly here this. So like a skilled mathematician would take a month to solve it, and he would never solve it. And he looks at it and says, well, the answer is, I think, like this and this and this. And wait here. The thing is, I have this in another sheet as well. Now, the thing is, this is associative brain. And if you have your part that is the slow thinking part, that is logical. It's serial. So you make a step, you question it, you say yes or no, and then you move on. Very slow, but logical. This one is only associative. Now the thing is, the secret is, and I think I succeeded very well in that, is to train your brain all the time without filters, so that the logical and your associative brain, the slow thinking and the fast thinking brain, are aligned. And that's fantastic. It's like Mozart. I think Mozart couldn't have written a bad piece of music, because his, like, the objective sound of the music, where you could say, oh, contrapoint and this and that matched exactly his fast-thinking brain. So he was able to produce music, great, brilliant music, just intuitively. And I like the scene from the film from, I think it's Foreman, Amadeus, the film where the king played a piece from Salieri, and then Mozart, I think he had a little encounter with a maitresse in the palace, and then he arrived late, and he just heard the music the king was playing, a little bit clumsy, and then the king said, "What do you think about the? Yeah, it's nice. Yeah, it's nice." And then, would you want to play it? Here are the notes, and he said, "I don't need the notes. I just play it." And the thing is, Mozart just played it, and he then played the thing out of his head. Why? Because his associative thinking had found systematic things in here. He remembered it immediately, and he immediately saw, oh, there was a little, hey, look, this part could be improved like this. This is a little bit, boring. This is boring. Could we put this in? Doesn't that sound better? Yeah, this sounds better. Look at this. That. And so that's a difference. So you would say, here's Salieri, here is Mozart. And I think what I say is we can all become Mozart, but it takes, and that is a rule of thumb, it takes 15 years. Yeah. And now the thing is, do you want to invest 15 years for what? So it depends. What is your vision? What do you want to achieve? How much time do you have? What do you want to do? Eat chips and watch Netflix? It all has pros and cons. But I think almost everybody can do that. Well, there's a lot of people then tell me, oh, I can't do it. Well, yes, you cannot teach, for example, a rabbit to then become an opera singer, because he just hasn't got the brains and the vocal strings and so on. But in limits, if you have a reasonably intelligent person, a person whose brain works, then give him 15 years and of huge training, make him resistant, make him be able to concentrate for a long time and so on, and he'll become really, really good in anything he wants to learn. He wants to learn, if it's his vision. Okay, that's it. It's 1 hour and 8. And because I mentioned, sorry, I put that in because I mentioned here the sigmoid function. So that is why I want to put that in. The sigmoid function is, the trigger was because I asked myself whether a human, like you take human A, Anton or whatever, does he have a globally fixed way of thinking? Like, is he a critical thinker? Is he somebody that always says yes? Is he, whatever? And I think that is the case because it depends on the sigmoid function. And there's a funny thing with the sigmoid function. When I think it was 35 years ago, I tried to program a neural network. I went to biology books, there was libraries and not the internet, so biology books, and I looked at a nerve cell and the synapses and so on, and I thought, great, I just programmed that in my Apple. I had an Apple IIe, and I thought I can program that, and then I invented a little camera window, 5 times 4 pixels, and then the network, and I had synapses. I designed it as I think it was 4 levels, and I connected them each other, and each one had like 4 connectors, and then I tried to simulate it. But I had the function when it fires something like a stepped one. I had it. How would that then be? I think something. I think I had it like this, and then I played around with it, and it didn't work, and it didn't train, and it didn't understand anything, and I played data in, and it didn't train, this idiot, and I tried to put a pixel in like that, and it nothing, and it didn't work. So and then 2 years later or so, I learned that there is this function, and so maybe with this function I could have actually do you call that inhaled intelligence into IQ? So I could have inhaled intelligence into my little neural network. The question here is the sigmoid function of our cells per person, per brain, similar? And can you, plasticity of brain, can you influence it? Can you change it? Maybe taking drugs. It's not like illegal drugs, drinking water or eating something special or something like that, or longer time, or being happy. Somebody laughs for an hour and then his sigmoid function changes. So maybe it changes like that, and then that means he has more. Then maybe he has more thought cycles because this changes, or maybe also the speed changes. I don't know what. That's the sigmoid function, and that's all for now. Thank you very much for listening, and talk to you next time. Bye bye.